Welcome, everyone. My name is Adrian. I am AI software evangelist at Intel. And today I would like to prove that deploying personal AI assistants with large language models, voice, and RAG is possible via OpenVINO on the AI PC. And before we start, I would like to show you our team responsible for that project. So not only me, I'm here, of course, to present that, but there is also Anisha, Juwo, and Raymond who contributed to this project. So praise to them. And let's start with the introduction of the application itself. So personalized assistant, by default, it's a healthcare assistant in this project. So let's imagine you enter the surgery. You would like to visit a doctor, but of course you first uh, meet this assistant at the entrance, and it's starting conversating to you, asking about some details, your name, address, and everything like that. Also getting symptoms. So doesn't sound good? I think it should, right? Because then the doctor may focus more on your problem, on your treatment, instead doing some paperwork. So how does it look? Let's play the video, and we see that we have a nice Gradio interface, and then we use our voice input to conversate with this algorithm. And so we use transcription for that. Then we have a chatbot where it interacts with you. And so you answer questions, you add additional information, you talk about your symptoms. And after the conversation is done, the chatbot is able to do the summarization for the doctor. So you are prepared already in the system of the surgery. Everything is already there, and the doctor can focus only on your problem. So this is how it looks like. And of course, by default, as I mentioned, it's healthcare assistant, but you can easily customize it to be an hotel concierge or agriculture assistant or anything like that. I will talk about it later. But first, what we use in this application. So our software stack consists of Whisper. This is the model for transcription. Llama, a chat model for our chatbot to interact with the user. Gradio for a nice web interface, and OpenVINO for fast inference on Intel hardware. And the hardware we can work with, you have listed on the right. So we can run on Atom, we can run on Core Xeon CPUs, as well as Intel Core Ultra, the one of the latest Intel CPUs, but also we can run on discrete GPU cards like Arc or Flex, and integrated GPUs or NPUs, which is neural processing unit, the device included in Intel Core Ultra. So this is how it looks from the general point of view. And the solution itself, as I mentioned, consists of Whisper. Whisper is a model responsible for doing the transcription of your voice to the chatbot. And then we use Llama. In this specific case, it's Llama 3.1, which interacts with the user and does the summarization at the end. So let's look at the code. First, before I introduce you some code, before I showed you how it works under the hood and everything like that, I need to tell you a few words about OpenVINO, because it's a crucial thing in this type of project. So OpenVINO is open source toolkit for optimizing and deploying AI inference. And OpenVINO means open visual inference and neural network optimization. So it started as a solution for computer vision, but it's no longer for computer vision only. It's also for NLP processing, audio, large language models, Gen AI, and transformers, and many, many more. And as I mentioned, it's open source. It's licensed under Apache 2.0. So you can go to our GitHub and find it and compile it yourself, and so on and so on. So this is first. But it's not the only thing we have used here in this project. How many of you already know transformers or diffusers, the Hugging Face API? I hope many of you. And what's nice with the Hugging Face API? The convenience of using that API when you don't have to do pre-processing or post-processing yourself. You can just use these libraries. So we decided to create an optimum Intel library to combine the convenience of Hugging Face API with the efficiency of OpenVINO. And why I am mentioning about Optimum Intel here? Because we will use it very heavily in this project. So convenience of the API and OpenVINO performance gains. And to talk about this project, we will talk about a few stages. The first three stages, installation, optimization, and running the application, are like for playing. It's a playground for us. But when you like it, when you say, it works pretty nice, I would like to use it, I would like to deploy it. So then we will also cover how to deploy it and further how to customize it so you can use it for your purposes, like, for example, changing the behavior and so on and so on. That's why we call it a productized stage. Good. So let's start with the installation. This project is also open source, so you can go to our GitHub and then clone the repository, change the directory to custom AI assistant. This is the name of this project. Then you need to create a virtual environment and install all requirements in the next step. And that's all. That's all. Just these three simple steps to have it ready on your computer. But this is just installation. Let's go to the next step, optimization. And before I show you code, I need to talk a little bit about weight compression because it's a very important thing in this project. So when you have your deep learning model, it's in floating point 32 precision. Then you train that model, it's still in floating point 32 precision, and then you have this model trained in the same precision. And then we can go even further and we can change the precision. So we use a weight compression algorithm to change the model precision from floating point 32 to int A. And the question is, why would we do that? Why we change the precision to lower? So the answer is on the next slide. Let's look at the middle rows when we have Llama 2 and the floating point 32 precision model has about 25 gigabytes of size. And when we change the precision from floating point to int A, the next row, the model size is reduced to 6.3. Super cool, isn't it? And at the same time, when we look at the perplexity, and perplexity in this case is a metric which is assessing how the model, how bad our model is. So perplexity in the floating point 32 is 3.28. In the when we convert the model to int A, it's 3.29. So it was increased by just 0.01. So I would say it's negligible. Okay, we can go even further and quantize all of our weights to int4 precision, the next row, with some additional parameters, of course, like asymmetric quantization group of 128 or ratio of 80%. I will explain a little bit about that later, but we can see that we can reduce the model size even more to 4 gigabytes, but at the same time, nothing is for free. Our perplexity increases by 0.14. Is it okay? I believe in this case it's okay to have it the perplexity equals 3.41, and I will show it a little bit later because in this project we do the quantization, the int4 quantization. But 25 gigabytes versus 6 gigabytes versus 4 gigabytes. Does it make any change? I think yes, of course, 25 gigabytes versus 4 gigabytes of disk space probably is not a big deal in Disk space is quite cheap. But think about your bandwidth when you need to download this model, or even better, think about your RAM usage. So 25 gigabytes, are you able to put this into your memory if you have just 16 gigabytes of RAM? Probably not. But what about Int8 or Int4 model? 6 gigabytes, 4 gigabytes? You can fit it into 8 gigabytes of memory. Quite easy. Good. So let's look how to run this quantization with the code. So we use convert and optimize ASR script when we specify the model we would like to convert. It's Distil-Whisper large V3 and the precision of Int8. What we need to do in the code to achieve the result, to convert and optimize that model, we need to import a few OpenVINO classes, especially in this case, it's OpenVINO model for speech sequence to sequence. Then we specify the model we would like to convert, and then we create that class when we specify the model name, of course, and then 3 additional parameters. Export equals true. It means that this model will be exported to OpenVINO. Compile equals false. So it means that we are not going to compile this model to use for inference. Remember, this script is only for conversion. We will do inference later. And load in 8-bit equals true when it means that the model weights will be quantized to Int8 precision, which I already explained a few slides back. Good. Then we save this converted and optimized model to disk, and we do similar things to auto processor, which is also needed for pre and post processing for Whisper. In this case, we are not converting anything. We are not optimizing anything in just simple processor. So we are just downloading and saving to the disk. Good. So it's done. Whisper is done. Right now, it's time to focus on Llama. In this case, we will use convert and optimize chat script when we specify, once again, model name and precision. So what we need to do, here we import another classes for OpenVINO, like OpenVINO model for casual LLM, OpenVINO quantizer, and so on and so on. Then we specify model name. Then we create that model by calling from pre-trained function. And there is one difference between the previous slide, Whisper, and this one, because here we have load in 8-bit equals false, because we don't want to quantize our weights to 8-bit, because we will go for 4 bits. So yeah, let's specify that configuration for quantization, 4 bits, asymmetric quantization, and a ratio of 80%. It means that 80% of layers will be quantized to int4, and the remaining 20% will be quantized to int8. Why that? Because if we quantize all layers to int4, our perplexity may increase to high, so that the model will not be so accurate as before. Then we create the quantizer when we specify also that our task is text generation, and run the quantization weight compression itself. You can see even that weights only equals true. It means that it will be weight compression algorithm, and that's all. The model will be saved to disk, and we do similar things for tokenizer. When I say similar, we download it and we save it to disk without any conversion or optimization. Okay, so let's look at the solution workflow again. We have a Whisper model, we have Llama model. So we start with the voice, then we use Whisper for transcription, then we use this transcription to conversate with the chatbot. And at the end, we have the answer for the chatbot, or we have the summary. Let's look how it looks like in code. To run the application itself, we need to use app script with the additional parameters like path to our models. These models we already converted and optimized. And how does it look under the hood? How this script looks like? Well, I'm presenting here just the most important snippets of code. Of course, the script itself is much longer, like more than 200 lines of code. But of course, I'm not going to present all of them here. Some of them are related just to interface and so on and so on. So I'm going to present just the most important ones to understand how the transcription function works, or how the chat function works. So let's import once again a few important libraries in Python. Then let's load our model. So we use OpenVINO, a model for speech sequence to sequence. And in this case, there is one more parameter. Of course, beyond the model path, it's device. And device equals auto. What does it mean? Well, we need to specify device we would like to run the inference on, for example, CPU or GPU. We can do it explicitly. As I said, CPU, GPU here. But we can also go for auto, when auto will decide what device is the best for us. So if you don't care, if you don't know which device is best in this case, just go for auto. Auto will do it for you. Good. And the transcription function looks like the following. So first, what we need to do, it's simple pre-processing. So we need to resample our audio, because Whisper model was trained with 16 kilohertz of sampling rate, and we need to do the same for our input, otherwise Whisper won't work for us. So we are resampling the audio. Then we use our ASR processor for pre-processing when we get input features of this audio. And then we use generate function from ASR model, and giving the input features and getting the transcription. That's all. And then we return it. It's text transcription. It's, I don't know, 10, 15 lines of code to run the transcription with Optimum Intel. Super cool, isn't it? And this is transcription only. So this is only the first part of the application, right? The second part, let's also see how the chat works. Once again, when we need to import a few things, OpenVINO model for casual LLM, auto tokenizer, auto config, and so on. And then we specify our configuration for OpenVINO. In this case, the most important thing is that performance hint equals latency. It means that we care about latency. So the response should be as soon as possible after we ask any question. Then we create that model, OpenVINO model for casual LM. We load it from the disk. When we specify also device equals auto, as I said, it's the same here. You can use explicitly CPU, GPU, auto for people who don't know what device to use or don't care. Then we also create a tokenizer. Tokenizer, in this case, is needed for pre and post processing for chat models. Then the chat function itself. First, what we need to do is to apply chat template. Every chatbot was trained with some template. So it means that there are like separate sections for system configuration, user, assistant response, and so on and so on. And we need to use the same template, otherwise our chatbot will not understand us. So that's why we do this. And then we need to tokenize the input. So computers work with numbers. We know that, right? So text is also, it can be also presented as numbers. For example, every letter could be a number. But in this case, it's better to just have a dictionary. And so the token means that this word is in the dictionary at position X, for example. So we are changing these words into this text into tokens, because tokens must be provided for the generation function. When we additionally provide a few more parameters, like how many new tokens we can generate maximum, or what is the temperature, top P, top K. I'm not gonna go into details here. It's quite usual for all chatbots. If you are interested, you can just go and search in the internet what all of these parameters mean. And our chat model generate for us also tokens. So tokens as the input and tokens as the output. So then we also need to decode those tokens into text. And that's all. So this is how it looks like. And this is our playground. So we already installed the project. We already optimized and converted and optimized Whisper Llama models, and we ran the application. So let's go to the next stage. What if you like to deploy? What are the options? So of course, you can go for cloud when you have just one big server and you can connect from many from many users, from many clients, and so on and so on. The pros, of course, you have almost unlimited computation on demand. You can process large amount of data, and so on and so on. But nothing is for free. At the same time, you need to send your data to the cloud. So what about data privacy? Maybe you are not allowed to send any data anywhere. What about high latency? Are you sure that your user has a good internet connection? What if there is no internet connection? How to work with that? So maybe let's deploy on the edge, like very specific industry specific devices, like kind of Raspberry Pi and so on. Pros, of course, data is no longer at risk. You don't you don't send it anywhere. You have an increased control. Probably also it's much cheaper solution. But at the same time, the power computation power is limited by local resources. So the question is there anything between, like having some pros like edge devices, but also some pros like cloud? We believe there is also AIPC. And AIPC is a wide range of consumer-specific devices. And when I say AIPC, it's nothing special, right? It's not like something you need to have access to, very difficult to find. No, it's just a standard laptop. You go to the store and you find it. The only difference is that it must have Intel Core Ultra inside. That's what makes it an AIPC. And the pros, the same as in case of Edge, data sovereignty and cost efficiency, increased control, and so on and so on. Cons, similar. The compute power is limited, but it's not as limited as in case of Edge. So if you would like to deploy this solution, we really recommend you to try with AIPC or any laptop. Of course, you can go for cloud if if it's okay to send data to the cloud, if it's okay to wait for the responses because of high or low latency, that's okay. But our recommendation is try it with our AIPC. And yeah, I mentioned that in the Core Ultra, this is something what makes the laptop AIPC, and it consists of three devices: CPU for fast response use cases, GPU for high throughput, and NPU, which is neural processing unit, for low power solutions. And that's what we need to run this project on. Good. We know already options for the deployment. So what about customization then? The next very important topic. We have plenty of ways of customization of this product. So you remember the solution workflow, right? Whisper, Llama, and so on. We can also add here RAG, which will provide additional context for the responses of the chatbot. So what this RAG is, let's assume that you have a few documents. Let's say there are 10 PDFs with the knowledge of some guidelines or in your company, right? Then we load all these files to memory. We split them into chunks, like let's say that the PDF files are very long, 100 pages or so. So we split them into chunks, like every chunk has just one page. Then we use an embedding model to create embeddings It's like, when you compare it to like usual database, it's like index. So we will search for interesting chunks using this index, the vector of embeddings. And then we use those embeddings to store in some database. So right now we have all of our knowledge with from these PDF files into our database, and they are ready to be searched. But this is only the first stage. The second stage is querying that database. So let's say the user comes and asking some questions about anything which was stored in these PDFs. Then we embed the user question using the same embedding model, and we are trying to retrieve all chunks which are related to that questions. And then when whatever we get, we add the prompt. So the prompt looks like this. User is asking, what are the rules in this company? So we are looking for the rules in these PDFs, and when we find it, we add it to the prompt. So the prompt looks like, based on the following context, and there are rules of the company, please answer this question. And there is a question from the user. What are the rules in this company? And then we use large language model to generate the answer. So we use pretty much the same what we used before, but we need to use a new library for that. And in this case, we decided to go with Llama Index because it's a very popular solution. We need to import a few more classes. And then we create OpenVINO embeddings model. We specify that we will use it for our pipeline. Then we create also OpenVINO large language model. It's very similar to the model we created using Optimum Intel. So Llama Index uses Optimum Intel under the hood. So this is just a wrapper in a new framework because we need to have, we would like to have a RAG pipeline. Then we load our documents, we create the database from this document. So, the embeddings happen exactly here. So the database is already ready to be searched. And then we create the chat engine from this index. And any questions the user will ask, it will be answered using the knowledge from the documents we just provided a few lines above. Good. So that was the first customization. The second customization is multi-language support, as Whisper is trained on English language, but it's not a problem to change it to something else. It must be just a transcription model for another language. In this case, we can use, for example, Bell Distil-Whisper v2 for Chinese language. The same for Llama. We don't have to use Llama only. We can use also Queen 2 model, which is also fine-tuned on Chinese language, and we do it like this. Then, of course, when we run the application, we need to provide paths to our new models instead English models, and then it will work in Chinese language. And the next thing we can customize here is very important one. We can change the prompt. So here we have a healthcare assistant, but there is no problem to change it to something else. We can say, you are a helpful, respectful, and honest, let's say, hotel concierge. No problem. You can also limit how many questions it should ask. You can say what you can get from the user, what you cannot ask, something like that. So it's super simple. You just need to change, I would say, a few lines of code, but it's not even code. It's just text. It's just a prompt, right? And you can have a new chatbot working as a work assistant, hotel concierge, agricultural bot, or anything you want. So the most important slide is here. Scan this QR code, go to our GitHub, clone the repository, install our requirements, optimize, run, play with it, and see how it works for you on your computer. And this project is part of our Edge AI reference kits. So there are even more kits. So I also recommend you to scan this QR code because you can learn how to count people, for example, in queues using our intelligent queue management. You can also learn how to read the values from analog and digital industrial meters, or you can detect defects with anomaly. So once again, scan the QR code and check out all of our kits. And that's all from my side. I hope I already proved you that it's possible to run any personal AI assistant on your laptop. And the most important thing, don't believe me, try it yourself. And if you have any questions after this speech, please find us on LinkedIn and ask the question there. We always respond. Thank you very much for being here, for watching this, and hope to talk to you soon.